All right, welcome back, everyone. We're going to continue on our discussion of Division 9 finishes corresponding to Book Chapter 9. This is Part 2. Last time we covered wall coverings, plaster, drywall, acoustics, and also painting. This time we're going to move over to floor coverings, and we're going to look at tile, terrazzo, carpet, wood, things like that. So let's go ahead and get on with it. So like I said, this corresponds to Chapter 9, in particular with the floor. We're talking about 9, 6, 10, 11, 12, and 14. Before we can talk about our flooring and placing our flooring on a surface, we have to talk about the subfloor. What is the flooring surface that we're going to apply this flooring to, and what do we need it to? What are some characteristics of that? Whether it's wood or concrete, we need it to be dry. We can't have a wet surface, because if we have moisture issues, then when we put down our adhesive or whatever else we're doing to attach these materials together, we won't get a good adhesion, a good stiction between our materials. We also need it to be flat, smooth, and level. So if I have flooring that is a little catawampus, sloped in a weird way, I may need, if it's concrete, a leveling compound. If it's wood, it may need to be sanded or whatever else, because these deformations, these characteristics will show through when we actually apply our floor. Also needs to be clean. Same idea with this bonding, this adhesion. If I have sawdust or some other material in there, of course that will keep it from adhering. Deflection is a consideration. So what do we mean by deflection? If our floor can't support the load, the dead load and live load, we talked more about dead load and live loads before. If it can't support it enough and we have deflection, almost like a bouncing, then we can get cracking of our tile. We can get our wood will pull loose and we'll start to get creaks. And as a general guideline, and actually by code, the way we define this deflection, how far it can go down, is 1/360th of the span under the total load. For instance, if I had, say, some flooring, and say this span here was, we'll say 20 feet. For 20 feet, how much deflection can I have in the center would be how much it can sag down, and that would be the length over 360. So I'd have 20 feet times 12 inches per foot. To convert that 20 feet into inches, divided by 360, and that gives me something like 0.67 inches, right? So what that means is that for my deflection, that little distance can only be less than 3/4 of an inch to be fully supportive. So if it isn't supportive, it means that either the floor members, the joists, are too small, or there's something else going on there as far as my spacing or something else, right? So you'll see that more in structures class for the CM majors, but a basic principle of how much deflection we can have. When we talk about the types of tile, we can have many varieties. We can have ceramic. Ceramic's by far the most common. It's made out of a clay, and you can have many different designs and patterns and styles. We can have a porcelain. It can look more like a natural stone, brick, or wood. So these are becoming more and more popular, where it looks like a wood floor, but it's actually made out of porcelain. And that means that it's waterproof, or at least highly water resistant, versus a wood would absorb that water. That's why you'd want to do a fake wood, right? You could have glass, typically more on walls, right? But a glass tile is stain resistant, smooth, but it can chip. You could have a cement tile. Big advantage to cement is you get a ton of different variety for colors and patterns, and those are usually more of a artistic type of tile. Unfortunately, they are extremely porous, and so what that means is if there's all these pores, if you spill like a red wine on there or any kind of staining type of thing, it absorbs into the pores and you'll never get it out. To keep that from happening, what we do is we seal it. So we put the sealer on top of it, it goes into the pores, keeps everything else from going inside the pores. Problem is that has to be done on a yearly basis or so, depending how porous the material is. and what you use as your sealant. But that's what it means by sealed and resealed. It's the same thing with natural stone. So granite, marble, travertine, slate, limestone, sandstone, those are all examples of natural stones. All of those are porous and need to be sealed. So as ceramic tile is the most common, expanding on that, different types of ceramic tile, we could have a glazed wall tile. Usually those are these smaller 4x4 inch or so where you see in a pattern, right? We could also have a mosaic tile. So the mosaic tiles are the really small squares, usually with a lot of different colors and things. We could have a paver tile, usually about 6 square inches or larger, but otherwise it's generally similar to the mosaic. We could have a quarry tile. Now we're talking 9 square inches or larger, used on floors, usually unglazed. And decorative or commemorative tile, well, that's kind of self-explanatory, right? Decorative meaning more bright and colorful and things like that. When you talk about the ceramic tiling, the reason it is so popular is because it has this great resistance for abrasion. It doesn't get scratched up, right? We can have this variety of colors and patterns, and we have a high degree of moisture resistance. Excellent for areas of foot traffic, intermittent contact with water. So all these great things. It also isn't very expensive. This is why ceramic tile is by far the most abundantly used material as far as your tiles. When we talk about installing our tile, basically what we're talking about is what's going to stick the tile down to the subfloor, right? 2 methods, either the thin set or thick bed. Thin set means that we have like a mortar type material. We talked about mortar before with bricks. Same idea with tile. It's the part that sticks it together, right? Don't confuse that with grout. Grout, just like with bricks, was the part that fills in the gaps. Same idea. Mortar sticks. Grout fills in the gaps around the sides, right? So grout used to fill the joints between the tiles. When we talk about these, it could either be mortar based or it could be epoxy based for the adhesion part. When we talk about the grout, it could either be made out of a cement or a resin. The other 2 things we should consider is instead of the thin set material, we could have a thick bed, and as the name applies, you're talking about a thin layer of material, thin set versus a thicker bed. And the thick bed tiles are placed in an unbonded isolated setting bed, right? So unbonded meaning not bonded with the subfloor so you can actually move. Here we see the tile installation. The first step is to apply this whole layer of your mortar. So you can see he's applying this mortar. The reason we have these ridges here is when we put our tile against that mortar, it basically allows it to push the air voids and create a very good suction, right? So you end up with this suction. And you can, if you've ever laid tile, if you put the tile against the wall, put some pressure on it to push it into place, and then try and pull it out, it does not want to come out. And that's not because your mortar has set, it's just because of the suction with the air pockets in there. So that's why we use this trowel with the little ridges to give me this pattern. But regardless, the first step, put on that mortar. Then we place our tiles. You can see he's tapping them into place, pushing them into place. We make sure these are all level with each other, setting them all up, and then we come back and here he's grouting them in. So we have this grout where you're moving your float at like 45 degrees. Kind of fun doing tile work. If you haven't done it, you should definitely give it a shot. Here we see it again, still putting down a full mortar bed. As an alternative, one thing you could do, and in tight corners you'll do this, is you could butter the tiles themselves, buttering the back of them, where you take your mortar and you're just basically using your trowel and you're putting it on the back of the tile, then setting it into place. When we talk about this mortar, the part that's sticking it down, like I said, there's really 2 different types. You could either have a mortar or more of an epoxy based. I think the mortar is much more common, but you have different types. Each type will have its own description, its own industry standards, and of course there could be limitations to it, right? So Portland cement versus a dry set, latex, Portland cement. Then you have your epoxies. Epoxies mean it's a 2-part system mixed together. Once they're mixed together, it starts to cure or harden. We can have an epoxy mortar, epoxy adhesive, Furan mortar, organic. mastic adhesive. So a number of different varieties, and I'm not going to read all these, but you could pause this and read through it if you want to know the differences between your different mortars. Same idea with the grouts. Many type of different grouts out there. We have our Portland cement grout, sand and Portland cement grout. Really a difference between a sand, more of a sandy grout, and non-sanded grout is that your spacing between your tiles. If it's a really tight spacing, we can't put the sand in there because the sand would create little voids. We'd need it, and if it's wider, we need the strength, so we put in the sand. So really that's the difference between sand and non-sanded grout. We could have a dry set grout, latex Portland cement, silicone rubber grout, epoxy. Once again, there's that epoxy. I could use that for the grouting process as well. And furan resin grout. And same as before, I can see the descriptions. I can see some limitations. So figuring out which mortar and which grout per what kind of tile you're using, and more importantly, what size. Is it going to be interior, exterior? Is it going to be exposed to water? Things like that, right? All right, so when we talk about tile installation on concrete itself, so now we're saying right on top of concrete, we really can get a good bond here. There's two ways you could do it. You could either do this thick bed or you could do thin set. As you can see, we're basically talking about the thickness of your mortar. Concrete surface should be steel troweled and fine broomed. What you're doing is you're creating a surface that the mortar will stick to, right? Concrete surface should be thoroughly moist cured before tile application. So that means it should be totally set up. It's not going through the curing process, and it's a strong, durable concrete surface. It's not going to have the top layer fall off or anything. Liquid curing compound should not be used since they can reduce the bond with tile. So you do need to when you're talking about the curing of your concrete, there was one process we talked about where you could put a liquid on top that would seal in that moisture. That's not something you should do if you're going to put tile over the top of it. Over wooden subfloors, we can also have a thick bed or thin set, which you can see the difference here. Supporting joist space not more than 16 inches on center. It is to support this weight. Thick bed, single layer subfloor, 1 inch nominal boards or 5-inch thick plywood. So once again, we need a thicker subfloor because we can't have deflection between our joists, right? Thin set requires an additional underlayment over the subfloor. The idea behind that is with your subflooring, if you're on wood, it can suck the moisture out of your mortar, and that would decrease the bond strength, right? So as we've been saying with most of our materials, we have to account for the fact that there could be some movement or some change in length of our materials based on heat and cooling. So we can have these expansion joints. It does say not required for areas less than 12 feet wide, but when I get to the big, longer commercial industrial applications, that's when I need to start being concerned about these expansion joints. We can provide in the tile finish directly over the, we can have expansion joints, construction joints, isolation or control joints, where tile abrupts projecting surfaces and at proper interval over 24 feet in either direction. So I can see a couple different styles here. I can see in here how one would basically go inside the other as it tries to expand. This one has like a rubber membrane, which it can compress or expand as needed. All right, shifting gears slightly to terrazzo, a slightly different flooring material. Really old school material, been used back to the beginning of the Christian era. Used in the Roman times, and basically in the Roman times they used this crushed brick in a lime mortar. You can see some examples. You've probably seen this. I always think of like school building floors or things like that, older school buildings made in the 70s, 60s and 70s was probably the most popular time for terrazzo. It looks like almost like a fruitcake type thing, right? It's a durable, low maintenance floor finish suitable for interior or exterior. We have this decorative layer, which is the topping. That's really what we're seeing when we look at the terrazzo. It could be either bonded or unbonded, and either cast in place or pre-cast. So what is it made out of? It's made out of a cementatious material, the bonding agent, right? Which is like a Portland cement, which we've seen before, and then a resin or a resinous matrix made out of like an epoxy, a polyester, or polyacrylate, right? So it's either going to be an epoxy or it's going to be a cement based. Either way, it's going to have this decorative chips in there or pigments. And usually what it is it's ground down, and that's why it really shows, and then it's polished to polish all those chips. Other pigments, which dictates the color outside of the chips, in between the chips. We have divider strips and expansion joints we've seen before, because this is not individual smaller pieces, it's one continuous piece, so we do need places where it does stop to allow that movement. We can have metal reinforcement, mainly for the Portland cement style one. And then isolation membranes to keep, once again, for this expansion and contraction type thing, to keep it separate from other structures or part of the structure. And then curing compounds and sealing materials. We can seal it so it doesn't stain. Curing compounds help it set up. Now, like I said earlier, bonded versus unbonded. The real difference here is this isolation membrane on the unbonded versus bonded. You would not have that isolation membrane, meaning this side it's all, the subfloor is bonded to the terrazzo. The disadvantage to having it bonded is then you would need your subfloor and your terrazzo to expand and contract at the same rate, which may not always happen. That's the advantage to having an unbonded with that isolation membrane in between the two. We talk about the dividers, different types of divider strips to keep these pieces separate. You can see those: a thin top, heavy top, expansion strip, recessed edging, L divider, base bead, things like that. But all of them serve the same purpose, to have separation between different, in essence, like panels of this flooring. So moving on to wood flooring. Wood flooring, there's about 12 species of wood flooring that is our most prominent. Of those, hardwoods are definitely the most prominent. About 80% of wood flooring is made out of hardwood. The reason we like hardwood is because if the properties of hardwood they work out better for flooring. We said that it doesn't necessarily mean the strength of the wood. However, the hardwoods in general are more resistant to scratches or dog claw marks or anything like that, right? Also cleans up better, installs better, and we have less expansion and contraction. So what type of hardwoods are there? There's oak. There's many varieties of oak as well. Maple, beech, birch, pecan. And then on the other side we have our softer woods like a southern pine or Doug fir, a west coast hemlock. Remember, one of the main differences is is it deciduous or not. Sorry, these are all our deciduous versus our cone bearing, right? When we're talking about our wood, how is it going to be shaped when we actually install it? We have three different styles here. We have strip flooring, which is our skinnier flooring, up to 3 1/4 inch wide. So I can see that that's the width as I put it down. Versus a plank is a little wider, up to 8 inches, so 3 1/2 to 8. I can also have this idea of block wood, which is like basically a square piece of wood that would piece together. Now with all of these, we're going to have a tongue and groove type of system. We'll see more about that on the nailing, but basically, as you imagine, the tongues and grooves go together, giving me a rigid joint between any two adjacent pieces. Well, the reason it is tongued and grooved on two sides, grooved on two sides, is because I have to have it all around, have that same type of rigid support. So the general process is I have subfloor. Subfloor is usually some kind of plywood or maybe some planking. On top of the subfloor, I have paper or some kind of vapor barrier, and that's the idea, to keep the vapor out, to keep moisture, because we talked about hardwood before and how hardwood or wood in general, will change its dimensions as it soaks up moisture. So keeping moisture from the underside is very important, and it can be either a paper or some other type of vapor retarder like a plastic or a film, or there's some other specialty products out there. And then I can start applying my hardwood, and we could do our hardwood on top of the subfloor, or as an alternative, if I do have a concrete slab, I have to build up from that concrete slab, typically with these are called sleepers. So putting these 2x4s on end to give me something to nail to and support. I cannot put the hardwood directly on the concrete without it being an engineered wood or a floating floor system or something like that. So when we talk about attaching our hardwood, it's called blind nailing. I think we talked about blind nailing briefly. Basically what you're doing is you're nailing through the tongue of each piece. So I don't know about this picture. It almost looks like it would be drawn backwards, but you're always working with the tongue side out, and you're always nailing this way. So it should be nailed through the tongue. Either way, it's in the tongue. It's hidden. That's why it's called blind. And then as my groove goes over my tongue, it hides it in place. This is what a typical hardwood floor piece would look like. This one's slightly different. See all these different layers in here? This is called an engineered hardwood. What it means is we have plywood for a majority of this cross section, and then the actual wood. So this would be more like a renewable resource in a way, because if we look at an oak tree, and oak being the most common hardwood, it takes much longer for the tree to grow to the height needed, versus if I'm creating plywood, it's a much more sustainable resource. So the disadvantage to having this engineered hardwood flooring is that over time, the way we resurface our flooring is we can sand it down. And I can sand it until I get almost all the way to this tongue. It's like 4 or 5 sandings, which means hardwood flooring can last 100 years or more as I sand it down each time, right? Versus with this engineered, I only get 1 sanding out of it. So it's a shorter lifetime application process, right? This slide is showing a little bit more about these sleepers on end. If I have a concrete floor and I want to do hardwood flooring, usually you don't see hardwood on concrete flooring, but if you did, you'd have some kind of sleeper in here. Now I see the nails go in the right direction through that tongue, through this subfloor into the sleepers. And as an alternative, I really don't see this hardly ever. It's very frowned against as far as I know. I really don't want to do this, but you could glue your hardwood directly to the concrete using an adhesive, right? The only time I've ever really seen this used is if it's an engineered wood and you're actually having the plywood going directly to the concrete. Typically what you would do is a floating floor system where the whole thing's attached, and it's attached to each other but not attached to the concrete floor, so it allows it to move. Because as we know, wood is going to expand and contract, concrete is not. We can have blind nail. We talked about blind nail over the joist, and you could also glue it, I suppose, but very not used hardly at all. Moving away from hardwood into this idea of resilient flooring. What we mean by resilient flooring is it's resilient, meaning it's resistant to being indented. It also is quiet. It's dense, low maintenance. It's durable. Back in the day, a lot of these contained asbestos. We thought asbestos was the greatest thing ever because asbestos was a fire retardant. So we'd use it in walls and flooring and everything else. Later we found out that it is a carcinogen. It causes cancer. So of course now we don't use it at all. And if you are going to pull up an old flooring, you have to make sure it doesn't have asbestos in there, or we need to take it out in some kind of safe way, or cover it up and encapsulate it, right? So types of resilient flooring, we have vinyl flooring, vinyl composition, VCT, mineral fibers. We have these plasticizers and pigments, and PVC resin as a binder. We have vinyl tile, also PVC based. We have a rubber tile, a cork tile. Cork's become more popular the last 10 years or so, right? And we have linoleum. So those are really our resilient type of flooring we're talking about. Usually less expensive, usually lasts. And each one of these resilient tiles has its own standards, ASTM standards. You can see backing materials for these guys, some gauges, sizes, some ingredients, and what makes it up. So once again, you can take your time and read that, pause the slide if you need to. We can see some advantages and disadvantages, or really why we would pick one over the other. Why a vinyl over a rubber or cork, right? Location, BOS, B means below grade, O means on grade, S means suspended or above grade. You can see some might be used in better places than others. Also, what are they resistant to? Are we concerned about a grease-like environment? If so, we want a higher number here. Or stains, cigarette burns, resilience. What about the ease of maintenance, durability, quietness? What are your concerns about? And you can see how you would pick your resilient flooring from there. When you're installing it, you need an underlayment over your subfloors. And that underlayment can consist of either panels or mastic. If it's wood, it's going to be like a panel nailed to the subfloor. Mastic if it's over concrete. I can see they're doing that process right here. The mastic, what that is as these chemical binders which have this latex asphalt and polyvinyl acetated resins. A latex underlayment best for thin layers, and asphaltic or polyvinyl acetate better for thicker layers. We can have a lining felt used over panel underlayment, minimize joint opening and tile spreading. So this underlayment movement, we can use the felt to keep that movement from happening. Also adhesives. So if you have a thicker, that's what we really see here using this notched trowel. And if we're thinner, then we could just brush it on, right? Using almost like a paintbrush type thing. Some other accessories with this resilient flooring, we have to transition from one surface to the other. Here I see carpet to probably what is a linoleum or something, right? And then in between here I have this little transition piece. So if I'm going from wood to vinyl or carpet to vinyl or even hardwood, I have these little transition pieces. Stairs, treads, the part you're actually stepping on, risers, nose moldings, all of those can be added as an accessory. Same thing with wall base. Here we see some wall base right here. So moving over to carpet. Carpet can be made from either wool, nylon, acrylic, or a modified acrylic, which is a modacrylic, or polypropylene. What do we care about with carpets? We're looking at the durability of the carpet, the appearance, retention. Is it going to fade over time? The ease of maintenance and stain in static generation. Ease of maintenance would be stain. Static generation, if you're a kid like I was and you would rub your feet against the carpet to get that static electricity and go shock my sister. We did not have a static free carpet for sure. So breaking this down into individual things, the durability, what do we mean? Abrasion resistance. If I do rub my feet or if I vacuum, is there going to be pieces of carpet coming up all the time? Alkali acid resistance, insect and fungi resistance, burn resistance. I think those are self-explanatory, just the overall durability of the carpet. The appearance, retention, is it going to compress? Am I going to have depressions within my concrete? What about the texture retention? And I think color retention should be on there as well, because they're fading due to sun. Ease of maintenance, resistance to soiling and staining. How easy is it to clean? And then that static bit, right? What about if I'm working in electronically sensitive equipment? What if I'm in a computer lab? What kind of carpet? How would that be different than if I was just in a normal household application? Or if I want to shock my sister? What about installing the carpet? It can be put directly over finished flooring, subflooring, concrete, plywood, particle board, almost just about anything, right? Generally, I always think of these carpet strips. These are in either concrete or wood, where this one nail here is what's getting pounded into my subfloor, and then these little nails that are coming out, these tacks, are what's holding the carpet in place. So if you've ever seen this, it's like a knee kick, and you're kicking the carpet, stretching the carpet is what it's called, onto these tacks. So it's like a one-way thing, right? So the more you can stretch it, it'll just hold in place due to those tacks. So you imagine tack strips all around the perimeter of your carpet, stretching it into place. As an option, you might have a rubber-backed carpet, which is basically just free-sitting and hopefully won't move. Carpet can also be glued. This is more common for like carpet squares, something like that. If you have a picture of that. Yep, here's some carpet squares. So you can imagine these, I can't stretch on and use carpet strips instead, or tackless strips. Instead, what I would do is I would glue it onto this subfloor. Here's just another example of some massively big tiles. I think that's what it almost looks more like a concrete floor, but picture was with the PowerPoint, so it's still a type of flooring. These are definitely tiles, individual tiles. I can see an expansion joint here that goes through, things like that. And yeah, so that wraps up our whole idea of finishes part 2. As usual, if you have any questions or comments, let me know. I'll talk to y'all later. Thanks.